This is another one. This is tricky. You can plug in a number and put in a large thing and get, for some reason, the crappy calculator I downloaded gave me not an answer or not a number. So I think that on your calculator it'll work. I think it's something I downloaded. Here's what I did. So this is where fluency, they call it fluency. I don't like that word because that's usually a math teacher's excuse to give someone 50 complete square problems. You need to get fluency. But here's where it's important to understand what you're doing procedure-wise. See that fraction on top, 3 to the n plus 1 over 7 to the n? You can kind of see it?
It doesn't work.
Huh?
When you put in a calculator, it doesn't work.
It doesn't, so it gives you some, I can show you the answer and it's going to become clear. See that fraction that's on top? So when you were in, how many of you took Red Hawk Math here from the computer labs? When you guys were in there, they had you add things with common denominators a lot, right? So you can think of it as somebody added it, and now you're going to go backward a step. You're going to split it up before it was common denominator. So here, like if you added these two, you get right back to where you were before. So you're going backwards. I call it backward common denominators. Just split them up. What's going to happen to this guy?
Zero.
Big bottoms go to?
0.
Big bottoms go to 0. And this one here, if you factor out the n, you get 3/7 to the n. That's a fraction. And you're raising it to higher and higher powers of n. That goes to 0 too. So it's 0 plus 0, which is 0. So any number between -1 and 1, a decimal between -1 and 1, when you raise it to the n power, that thing goes to 0. Because you're just, think of 0.001 times 0.001. It just stacks more zeros in the front. So that's what's happening. The more and more successive powers you take, the whole thing gets a bunch of zeros stacked in the front. And of course, the big bottoms go to 0. There, so we got the answer put in Webassign. Does it feel nice when you put the answer in and you get it right and gives you the green check mark? We're pathetic. I just had a feeling. I wanted to show you stuff with exponentials, and the reason I wanted to show you that really cool thing with how people eat was because it uses exponentials. One of the girls from the 1020 class told me that she doesn't even know what those E things are. And so I thought, well, didn't you get that in pre-calc? She's like, they didn't cover it in pre-calc. And I thought maybe it's at the end of the semester in pre-calc. Is that correct? I think we reversed things in our pre-calc class. But the E's are really important. That's the one thing I have seen. And so I tried to find problems with E's in it, and here's one with E's in it. Let's find the answer first. Why did I put it in Excel? You can put in big numbers if you want, but I wanted to show you how to put it in Excel. E in Excel is EXP, and the parenthesis is the N. So E to the N is EXP of A2. That's how you plug in an E. That's where it comes from. And so I just put it in just the way you put your sequence in today on the computer. Same thing, except I put in wherever I have E to the N, I put EXP of A2 in this case. Greg, this is the way, obviously, you would program anything. EXP is the function in any programming language that I've seen where they use E. So E is a function. That's the way they think of it. So you can see from the graph, where is that converging to? To 0. It's leveling off at 0. In complete sentences, it's leveling off at 0, so therefore it's converging to 0. And I put the formula up there so you can see it and you can try it at home. Try as many of these Excel things as home so you can get used to it. It is really quick. I saw some people come up here, bam, bam, they got that problem done in 2 seconds and they were back at their desk. So it's really useful once you get it. So it looks like it converges to 0. So how do I do it? Well, I'm going to do the same trick. It's worked well for me before. I'm going to divide everything through by the highest power. That's e to the 2n. So I did that. And all I'm using here is laws of exponents, which is going to be on the front of your test because you have to write it down for me. So same basis, you subtract the exponents. Same basis, you subtract the exponents. Here you subtract. Here I got this. This is big bottom, e to the 2n. So where does that go? 0. So that wipes that to 0. These are what we call exponential decay. You might have remembered that from pre-calc. E to the minus x damped down to 0 quickly. That's radioactive decay. So if they actually wanted to know how old something is, and they look at how much carbon's in it, You have to take organic, don't you guys, as bio majors? Are you guys in that class? I wonder why people hate it so much. My sister didn't like it either. But you know, the carbon is how we tell how long something's been there. You know, you look at how much carbon has decayed, and it goes that way. What would happen if you went forever? How much would carbon decay? Wipe out to 0. So that's what happens to the top. 0, 0, 1, 0. Whole thing. So I put a little arrow there to tell you how do I know these go to 0. You have to know e to the minus x goes to 0 as x goes to infinity. That's one of the properties of e to the minus x. We call that exponential decay. When you have bacteria in the petri dish, that's exponential growth, the other way around. It's a flip of that graph. And that's the big bottom. That's why that one's 0. Oh, I see this? You guys asked me this question last time. You don't like me anymore.
No, just this problem.
Okay, I'm going to show you 2 ways to do it.
I
One
asked
with
my friend, he gave me this other way.